Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question which states that determine the equivalent inductance in the given network. So this is the network. Inductance is measured in Henry. H. So in this one, but the unit is just given in millihenry here. But the general unit of inductance is Henry. H, given by H. When the current flows through this circuit and comes to this point, a portion of it enters here and a portion of it enters here. When the current that enters here comes to this point, a portion of it enters here and a portion of it enters here. When the current also comes to this point, a portion of it enters here and a portion of it enters here. The same amount of current that enters this inductor, that's the same amount that enter this one. Hence, these two are said to be in series. So the method of finding equivalent inductance for inductors is the same as that of finding equivalent resistance for resistors. So if you know how to find the equivalent resistance of a resistor in a circuit, you will be able to find this for inductance. It's only that of capacitor that differs. So this one, since they are in series, just as how you do it in resistor in series, you add them. So you add L6 and L7. And when you find the total here, the current that comes here to this point, it divides into these two. So that means this L5 is in parallel with the sum of this. In this one, I'll be showing you a different method. In one of my videos that I found the equivalent resistance of resistors in a circuit like this, I used method, I was drawing the each diagram. When I add this, I draw a diagram and I put one inductor here. In that one, I put one resistor here. So I was doing, in this one, I'll just use a formula method. You can also use that of diagram. And the link of that my video is down in the description below. You can check it out. To choose, you can choose any method I want. So in this one, when the current comes here, portion will enter here and the portion will enter here. So L5 is in parallel with the sum of L6 and L7. So we can say L5 is parallel with L6 plus L7. Because different amount of current enters here. These two branches. So now when two inductors are in parallel, you use the easy method of product over sum. So the equivalent inductance here would be product over sum. So it will be L5 times L6 plus L7 over L5 plus L6 plus L7. We added L6 plus L7 because they are in series, and we are taking this in parallel because when the current comes to this point, a portion enters these two branches, which makes these two branches parallel to each other since different currents are entering it. And this one, since the same amount of current are entering it, made these two inductors in series to each other. So now the inductance for this is 100 millihenry times L6 is 40. Okay, L5, this is for L5, 50. L5 is 50. Is 50. No, 50. L5 plus L6 is what? 40 plus L7 is 100. 50 plus 40 plus 100. and 50 times 40 plus 100, 50 plus 40 plus 100. No, it's 36.8. 36.8 millihenry. So the equivalent of this branch here, this whole branch is 36.8 millihenry. So now, when you draw a diagram, this 36.8 millihenry will be connected in series to L4. So L4 and this 36.8 will be in series, and when the current comes to this point, it will split here. So this branch will be parallel to the sum of this and 36.8, like we did here. So in the same way, L3 now will be parallel to the sum of L4 plus 36.8, because 36.8 and this 20 millihenry will be in series. That's the L4. So in the same way, we find the equivalent inductance for that one. It will be L3 times L4 plus 36.8 plus L3, no, divided by L3 plus L4 plus 36.8. So L3 is what? Is 30. L4 is 20 plus 36.8. Okay, the above is times. Then this is plus 30 plus 20 plus 36.8. So it will be 30 times, this is times, this is plus, product over sum, plus 20 plus 36.8, 30 plus 20 plus 36.8. So it's 19.6. So here the answer is 19.6 millihenry. So the total branch from this point to here now is 19.6. So this L2 will be in series to 19.6, and L1 will be parallel to the sum of L2 and 19.6. So it will be L1 in parallel to the sum of L2 plus 19.6. So now the real equivalent inductance will be given by L1 times L2 plus 19.6 divided by L1 plus L2 plus 19.6. So for L1 is what here? 20, and L2 is what? It will be 20 plus 40 plus 20, to be 20 times 20 times 40 plus 19.6 divided by 20 plus 40 plus 19.6. So this becomes 20 times 40 plus 19.6, 20 plus 40 plus 19.6 plus 19.6, which is 14.97, approximately 15. This is approximately 15 millihenry. Since it's the final inductance, we just approximate it. So it will be 15. So it will be 15 millihenry. So the final equivalent inductance is 15 millihenry. That means the equivalent inductance of this circuit is 15 millihenry. Is 15 millihenry. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.